October 23, 1942. The Egyptian desert near El Alamein. Lieutenant Marco Ferri of the Ariete Armored Division gripped the traverse wheel inside his Carro Armato M 1340, watching through the narrow vision slit as dust clouds rose in the distance. Around him, 278 Italian medium tanks prepared for what would become the largest armoured engagement in North African history. 4 crew members in each machine, 104 rounds of 47mm ammunition, 4 Breda machine guns loaded and ready. What these Italian tankers did not yet understand was that they were about to face something that would fundamentally challenge everything they believed about their equipment, their training, and their chances in this war. The Americans had arrived with a tank that would expose the M1340 not through superior firepower alone, but through a geometric principle so elegantly simple that Italian gunners would watch their own shells deflect uselessly against armour they should have been able to penetrate. This is the story of how Italian tank crews discovered that modern warfare had evolved beyond their capacity to compete. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today, and how a 47-degree angle would prove more decisive than courage or tactical skill. The seeds of this revelation were planted years before in the design rooms of Fiat Ansaldo. In late 1937, the Italian Royal Army issued specifications for a new medium tank to replace the aging L3 tankettes and the flawed M1139. The Carro Armato M 1340 emerged from these requirements, named for its scheduled weight of 13 tons and its projected introduction year of 1940. On paper, the M1340 appeared formidable. It mounted a 47mm Breda gun in a fully rotating turret, a significant improvement over its predecessor, which had featured a hull-mounted gun. The armour ranged from 30mm on the frontal hull to 42mm on the turret front. The Fiat diesel engine, producing 125 horsepower, gave it a top speed of 32 km per hour and excellent operational range. Production began in late 1940 at Ansaldo Fossati factories, with Fiat supplying engines and Breda delivering weapons. By December 1940, monthly production reached 60 to 70 tanks. Over 700 units of the M1340 would roll off the assembly lines before production shifted to the improved M1441 variant. In total, more than 3,000 tanks would be built on this chassis, or its derivatives, providing the bulk of Italian armoured forces throughout the war. Italian commanders initially believed the M1340 represented their entrance into modern armoured warfare. The 47mm gun could penetrate British cruiser tanks at normal combat ranges. The armour provided protection against British 2-pounder guns. The crews felt prepared to fight. They had no way of knowing that the mathematics of armoured warfare were about to shift beneath them, and that the technological competition was accelerating far faster than Italian industry could match. The first M1340 tanks arrived in North Africa in late 1940, equipping the Babini Brigade. These crews received approximately 25 days of tank training before deployment, a fraction of what British or German crews received. Most units were hastily formed, lacking cohesion and experience. Many tanks initially lacked radios, forcing commanders to communicate through hand signals or by dismounting, a critical tactical disadvantage in fluid desert warfare. The baptism of fire came during Operation Compass in December 1940. At the Battle of Breda from January 3 to 5, 1941, Australian forces attacked Italian positions defended by M1340 tanks. In 3 days of fighting, the Italians lost 40,000 men, including 2,000 killed, 3,000 wounded, and 36,000 captured. The Australians suffered 456 casualties. Italian tankers who survived Breda reported confusion and chaos. Most vehicles had no radios. When British artillery opened fire, tanks could not coordinate responses. Many vehicles were destroyed before they could even engage the enemy. Those that did fire found their shells effective against British light tanks, but the crews were too few, too scattered, too unprepared for the coordination required in modern armoured combat. The problem was not entirely the tank itself. In early 1941, the M1340's main gun could penetrate most British cruiser tanks at normal combat ranges. Its armour was comparable to opponents like the British Crusader. The design was conventional but adequate for its time. The true weakness lay in training, doctrine, and support. Italian tank crews lacked proper instruction in combined arms tactics. Recovery vehicles were virtually non-existent, meaning disabled tanks were often abandoned. Maintenance in the harsh desert environment overwhelmed undertrained mechanics. By April 1941, when the German Afrika Korps arrived in force, the Italians fielded approximately 240 M13 and M14 tanks in first-line service. These crews had learned hard lessons from the early defeats. Training improved. New tank training centres opened in Italy. Crews became more proficient. Radios became standard equipment. Italian tankers learned to work with German units. They could fight, and fight they did. At the First Battle of Bir el Gubi on November 19, 1941, Italian M1340 tanks from the Ariete Division engaged British armour in a day-long battle. The engagement demonstrated that improved Italian crews could hold their own against British Crusader tanks armed with 2-pounder 40mm guns. Both tanks were vulnerable to each other's weapons at normal combat ranges. Both had weaknesses and strengths that balanced in conventional engagements. The battle raged across the desert as columns of smoke rose from burning vehicles. By late afternoon, British forces withdrew, leaving behind 42 to 52 destroyed Crusaders according to various estimates. The Italians lost 34 tanks. It was a tactical victory that showed Italian tankers had come far from the confusion of Bardia. They had learned their machines. They understood fire and maneuver. Given proper training and support, they could match their opponents in combat between conventional armour designs. During the Gazala battles in May and June 1942, Italian armour continued to prove effective in certain circumstances. On June 12, 1942, M1340 tanks from the Trieste Motorised Division engaged British Grant tanks in the fighting south of Knightsbridge. Multiple Allied tanks were destroyed in the engagement. Italian crews used speed and positioning to their advantage, closing distance to fire at tracks and vulnerable side armour. It was desperate work, but it proved Italian tankers could fight with skill and determination. Yet even as Italian crews became more proficient, the technological gap widened relentlessly. In early 1942, the British began deploying the American-built M3 Grant medium tank in significant numbers. The Grant mounted a 75mm gun in a hull sponson and a 37mm gun in the turret. Though the hull gun could only traverse 15 degrees, it outranged the Italian 47mm weapon and could penetrate Italian armour at distances where Italian shells were ineffective. The M1340's weaknesses became more apparent with each passing month. The riveted construction meant that when shells struck the armour, even without penetrating, the rivets could become deadly projectiles inside the crew compartment. The bolted hull plates had a tendency to crack under stress from repeated impacts. The two-man turret forced the commander to act as both gunner and tactical leader, slowing reaction times in the heat of combat. The engine, though reliable in operation, was underpowered for the tank's weight, especially when crews added sandbags or spare track links for extra protection. Tank crews recognized these problems. Many attempted to improve their vehicle's protection by piling sandbags on the glacis plate or welding additional track links to vulnerable areas. But these modifications made the already slow tanks even slower and increased breakdowns from overtaxed engines and transmissions under the added weight. The Italian army recognized the firepower problem. Beginning in 1942, each tank battalion included at least one company equipped with Semoventi 75-18 self-propelled guns mounting a short-barreled 75mm howitzer. These provided indirect fire support and could engage enemy armour more effectively than the tank-mounted 47mm guns. But the Semoventi were based on the same chassis as the M1340, sharing its mobility limitations and thin armour protection. By October 1942, as British forces under General Bernard Montgomery prepared for what would become the Second Battle of El Alamein, Italian tankers knew they faced a technological disadvantage. The Germans had brought their latest Panzer IV special tanks with long-barreled 75mm high-velocity guns. The British had improved their armoured force with new equipment, but no one in the Ariete Division fully understood what was about to arrive on the battlefield. The Sherman tank that would change everything. On October 21, 1942, 2 days before the battle began, reconnaissance reported that British forces had received substantial reinforcements. Intelligence suggested new American tanks had arrived in theatre. Italian and German commanders reviewed what information they had about American armour. Reports mentioned the M3 Lee, which the British called the Grant, mounting a Hull-sponsored 75mm gun. That tank they knew. It was formidable, but its limitations were understood. What intelligence failed to adequately communicate was that the British 8th Army had just received 300 brand-new M4 Sherman medium tanks, the most advanced American design yet deployed to combat. Only 252 were fully operational when the battle commenced, but even that number would prove decisive in ways that transcended simple arithmetic. Lieutenant Ferri and his crew conducted final preparations on the evening of October 22nd. They had fought British Crusaders and Grants. They understood the tactics required: stay mobile, use hull-down positions, aim for tracks and vulnerable side armour when facing heavier tanks. Close the distance to bring their 47mm gun into effective range. Work with German panzers to create crossfire opportunities. These were proven techniques that had worked in previous engagements. What they did not understand was that the Sherman represented something fundamentally different from previous Allied armour. Not just in firepower or mechanical reliability, though it excelled in both categories. The Sherman incorporated a design principle that would render conventional Italian anti-tank tactics ineffective through simple physics. October 23, 1942. Dawn broke over El Alamein. At 9:40 p.m. the previous night, nearly 1,000 British guns had opened fire in the largest artillery barrage since the First World War. For 20 minutes, shells rained down on Axis positions. Then the infantry assault began, supported by armour pushing through minefields under cover of darkness and smoke. By dawn, Italian and German forces were responding, with counterattacks across multiple sectors. The Ariete Division received orders to move forward and engage enemy armour pushing through Italian defensive lines. Crews climbed into their M1340 tanks, engines coughing to life in the cool morning air. The smell of diesel exhaust mixed with dust and cordite from the continuing artillery barrage. Lieutenant Ferri's tank moved forward with his company, approximately 15 M1340 tanks advancing in loose formation toward reported enemy armour concentrations. Through his vision slit, he could see dust clouds in the distance, the characteristic sign of tanks manoeuvring in the desert. German Panzer III and Panzer IV tanks were moving up on their flank. Italian Semoventi self-propelled guns took positions in the rear for fire support. The engagement began at approximately 2,000 metres distance, when Italian gunners spotted enemy tanks advancing through morning haze and dust. These tanks appeared larger than Crusaders, with a distinctive tall profile. Ferri immediately recognized them as different from any Allied tank he had faced before. The shape was wrong. The silhouette suggested heavier armour and a larger turret than British designs. Italian gunners opened fire at maximum effective range, their 47mm guns trained on the advancing enemy armour. Through the dust and heat shimmer, Ferri watched his gunner fire 3 rounds in quick succession at a range of approximately 1,500 metres. The standard engagement technique: aim for centre mass on the frontal hull. The 47mm armour-piercing shot had proven capable of penetrating British cruiser tank armour at this range in previous battles. What happened next made no sense according to everything Ferri understood about armoured combat. He watched through his commander's optic as the first round struck the enemy tank's glacis plate and deflected upward, the tracer from the armour-piercing shot arcing into the sky at a steep angle. The second round struck slightly lower on the frontal hull and ricocheted to the side, visible as a spark and a deflection that sent the shell spinning away from the target. The third round hit squarely on what should have been a vulnerable area but produced the same result. A bright flash of impact, a spark, and the shell deflecting away from the armor without penetrating. The enemy tank continued advancing without pause, apparently undamaged by 3 direct hits from a gun that should have been capable of penetrating its armor at this range. Around Ferri's tank, other M1340 crews were experiencing the same phenomenon. Italian gunners were scoring hits on advancing enemy armor, but their shells were deflecting rather than penetrating. Rounds that should have punched through armor plates were glancing away as if striking some impossibly hard surface angled to defeat their penetration. Ferri ordered his gunner to aim for the lower hull, thinking perhaps the upper glacis had reinforced armor. The next shot struck the lower frontal plate with identical results. Deflection without penetration. The mathematics were wrong. The 47mm gun-firing armor-piercing shot should penetrate approximately 70 to 80 mm of vertical armor at 1,000 meters. British intelligence had reported the new American tanks carried approximately 50 mm of frontal armor. That armor should be vulnerable to Italian guns at this range. What Ferri and his crew did not yet understand was that they were encountering sloped armor, designed according to principles Italian tank designers had never fully implemented. The Shermans' glacis plate was not vertical. It was angled at 56 degrees from vertical on early production models, later increased to 57 degrees. This seemingly simple geometric modification transformed 50 mm of steel into the effective equivalent of over 90 mm of vertical armor. When measured along the path, a projectile must travel through the plate. The Shermans' designers understood what Italian engineers had theoretically known but never prioritized in their own designs. An armor plate sloped at extreme angles forces incoming projectiles to travel through significantly more material than the plate's actual thickness. A shell striking perpendicular to a surface travels through only the plate thickness. A shell striking at an oblique angle must travel through additional material as it passes through the angled plate at an angle. The trigonometry is straightforward, but the practical effect is profound. The Sherman's 50mm glacis, angled at 56 degrees, forced incoming shells to traverse approximately 90 mm of steel. Italian 47mm guns could not reliably penetrate 90 mm of armor at combat ranges. German Panzer III tanks with 50mm guns faced the same challenge. Even the long-barreled 75mm guns on German Panzer IV special tanks found the Sherman's sloped glacis a difficult target, requiring precise shot placement. But sloped armor provided more than just increased effective thickness. At extreme angles, projectiles could deflect rather than attempting to penetrate at all. When Italian 47mm armor-piercing shot struck the Sherman's steeply angled glacis, the shells often ricocheted rather than trying to punch through the steel. The angle was too steep for the relatively small 47mm projectile to maintain its trajectory. Instead of deforming and attempting penetration, the shells bounced away, their kinetic energy wasted on deflection rather than armor breakthrough. Italian gunners watched in growing frustration as their rounds sparked off advancing Sherman armor without apparent effect. They aimed for turrets, which were less steeply angled. They aimed for lower hulls, hoping to hit tracks or running gear. Some shells found their mark and disabled tracks or damaged external components. But the Shermans continued advancing, returning fire with their 75mm guns that significantly outranged the Italian 47mm weapons. The Sherman's 75mm M3 gun could fire high-explosive shells effective against infantry and anti-tank positions, or armor-piercing shells capable of penetrating the M1340's armor from well beyond the range at which Italian guns could threaten Sherman armor. When Sherman gunners returned fire, their shells punched through Italian armor with devastating effect. The M1340's riveted construction meant that even non-penetrating hits could send rivets flying through the crew compartment, like shrapnel. Direct penetrations were catastrophic. Lieutenant Ferri watched 3 M1340 tanks in his company take hits and brew up within minutes of the Sherman's return fire. The Italian tank's unsloped armor provided little protection against the Sherman's 75mm armor-piercing rounds. The bolted hull plates cracked and failed under impacts, fuel tanks ignited, Ammunition cooked off with secondary explosions that tore turrets from their mountings. Italian tankers who could escape abandoned their vehicles. Those who could not died. The tactical calculus was brutally simple. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Italian tanks could not effectively engage Shermans from beyond point-blank range due to the sloped armor deflecting 47mm shells. Sherman tanks could destroy M1340 tanks from comfortable ranges well beyond effective Italian gun performance. Closing the distance to engage at point-blank range meant exposing Italian tanks to concentrated Sherman fire across hundreds of meters of open desert, while absorbing hits without the ability to meaningfully return fire. Some Italian crews attempted the desperate maneuver anyway. They increased speed and tried to close distance, hoping to reach ranges where they could aim for less protected areas or achieve side shots on enemy armor. Few succeeded. German Panzer IV tanks with long-barreled 75mm guns had better luck. Their higher-velocity armor-piercing rounds capable of defeating Sherman armor at longer ranges. But there were only 30 German Panzer IV special tanks at El Alamein, compared to over 200 Shermans in British service. By mid-morning on October 23rd, the tactical situation was clear to Italian commanders. The new American tanks represented a qualitative leap that Italian armor could not match. The M1340 tanks that had proven adequate against British Crusaders in 1941 were hopelessly outmatched against Sherman armor in 1942. Not because of crew skill or tactical competence, but because of fundamental design principles that Italian industry had failed to implement. The battle raged for days. Italian tank crews fought with determination and skill, using every tactical advantage they could create. They worked with German armor to create crossfire situations. They used terrain and smoke for concealment. They aimed for tracks and running gear when frontal armor proved impenetrable. Some achieved kills on Sherman tanks through persistent fire or lucky shots that found vulnerable areas, but the overall trend was inexorable. Over several days of fighting, the Ariete and Littorio divisions were used to cover Axis retreat as British forces, supported by their Sherman tanks, pushed through defensive lines. The Centauro division was virtually destroyed fighting in Tunisia. By the battle's conclusion, approximately 230 M1340 tanks had been engaged. Most were destroyed or abandoned when mechanical failures or lack of fuel made recovery impossible. Italian tankers who survived the Second Battle of El Alamein understood they had witnessed something more significant than a tactical defeat. They had encountered the product of an industrial system that could design, produce, and deploy armor, incorporating advanced principles at a scale Italy could not match. The Sherman's sloped armor was not secret technology. Soviet 34 tanks had demonstrated similar principles since 1940. German engineers understood the advantages, but American industry could manufacture sloped armor tanks by the thousands while maintaining quality control and mechanical reliability. The M1340's armor, by contrast, was conventionally designed with minimal slope on critical surfaces. The glacis plate sat nearly vertical, providing minimal angle to deflect incoming fire. This conventional approach simplified manufacturing and reduced the need for complex welded joints, allowing Italian factories to produce tanks quickly using available industrial capacity and workforce skills. But it left Italian armor vulnerable to increasingly powerful anti-tank weapons, while providing no geometric advantage against enemy fire. Italian tank designers had chosen conventional armor layout because it matched their industrial capabilities and simplified production. American designers chose sloped armor because their industrial base could handle the increased manufacturing complexity, and because they understood the tactical advantages outweighed production challenges. The result at El Alamein demonstrated which approach better served the requirements of modern armored warfare. For Italian tankers who had trained on M1340 tanks and believed in their equipment's adequacy, the encounter with Sherman sloped armor represented a psychological shock as profound as the tactical defeat. They had done everything right according to their training. They had scored hits on enemy tanks at ranges their instructors had taught were effective, and they had watched their shells deflect uselessly while Sherman return fire destroyed Italian tanks with methodical efficiency. The revelation continued beyond the immediate battle. Italian prisoners captured at El Alamein and subsequent North African engagements found themselves transported to prisoner of war camps in the United States and other Allied nations. Many expected harsh treatment. What they encountered instead challenged their understanding of the conflict they had been fighting and the system they had been defending. Italian prisoners held in the United States reported adequate food rations that exceeded what they had received in Italian military service. They witnessed American industrial capacity in operation, with factories producing military equipment in quantities that seemed impossible. They saw civilian abundance that contradicted fascist propaganda about democratic weakness and capitalist failure. They worked on American farms and in industries that desperately needed labor, earning wages, and experiencing treatment that bore no resemblance to the degradation they had expected. Surveys conducted among Italian prisoners of war in the United States showed that 95% rated their treatment as good or excellent. Fewer than 1% attempted escape. Thousands maintained correspondence with American families for decades after the war. Many immigrated to America in the 1950s and 1960s, seeking opportunities in the country whose tanks had defeated theirs in the North African desert. The transformation was not universal, but it was widespread. Italian soldiers who had believed fascist propaganda about American weakness and democratic failure witnessed firsthand the productive capacity of free markets and free people. They saw that American industry could produce Sherman tanks faster than they could be destroyed, while Italian industry struggled to replace losses. They understood that the sloped armor that had deflected their shells was not just clever engineering, but the product of an industrial system with depth, sophistication, and capacity their own nation lacked. The technical specifications tell part of the story. The M1340 weighed 14 tons with 30 to 42 millimeters of armor and a 47 millimeter gun. The Sherman weighed 31 tons with 51 to 64 millimeters of frontal hull armor, heavily sloped, and 76 millimeters on the turret front. The Sherman's engine produced 400 horsepower compared to the M1340's 125 horsepower. Both guns could theoretically penetrate similar thickness of vertical armor at 1,000 meters, but the Sherman's sloped armor made it effectively much thicker than its actual measurement suggested. But the deeper story is about systems, not just machines. Italy produced approximately 3,000 tanks on the M1340 chassis and its variants during the entire war. America produced over 49,000 Sherman tanks between 1942 and 1946. American industry built tanks faster than they could be destroyed. Italian industry could not replace losses at any sustainable rate. The M1340 required skilled craftsmen to build using riveted and bolted construction techniques that were labor-intensive and time-consuming. Production rates rarely exceeded 70 tanks per month. The Sherman was designed for mass production from the start, using welded construction and standardized components. At peak production, American factories delivered over 2,000 Shermans per month. One American factory alone produced more tanks than Italy's entire annual output. This production capacity was replicated across every category of military equipment: aircraft, trucks, artillery, ammunition, all produced in quantities that Italy could not match. Italian tankers who became prisoners witnessed this productive capacity in operation and understood that their defeat had been inevitable, not because of cowardice or incompetence, but because of mathematics. An industrial system that could produce 50 Sherman tanks for every M1340 Italy built would win through overwhelming material advantage, regardless of individual tactical victories. The sloped armor principle that made Sherman tanks so difficult for Italian guns to penetrate represented more than just clever engineering. It exemplified American industrial sophistication, applying scientific principles to mass production. German engineers understood sloped armor theory. Soviet designers had implemented it on the 34, but American industry could manufacture complex sloped armor plates at massive scale while maintaining quality control across tens of thousands of units. That capability demonstrated industrial maturity that Italy, with its smaller industrial base and limited resources, simply could not match. Italian tank crews at El Alamein learned this lesson through direct experience. They fired at Sherman tanks and watched geometric principles render their weapons ineffective. They encountered armor designed according to advanced ballistic theory and manufactured by an industrial system with resources and sophistication their own nation lacked. They survived defeat and witnessed American productive capacity that made their equipment obsolescence inevitable. Post-war Italy, rebuilt as a democratic republic, allied with the United States, Italian veterans who had fought against Sherman tanks and witnessed American industrial might became advocates for democratic capitalism and Western alliance. They supported Marshall Plan reconstruction that helped Italy develop a modern industrial economy. They built political and economic institutions modeled on American examples rather than the fascist system that had led them to defeat. The Second Battle of El Alamein marked a turning point in the North African campaign. British and American forces pushed Axis armies westward through Libya toward Tunisia. Italian armor continued fighting with M1340, tanks supplemented by improved M1441 and M1542 variants, and semoventi self-propelled guns. But the obsolescence that became apparent at El Alamein never reversed. German forces received newer Panther and Tiger tanks. Allied forces received improved Sherman variants and other modern armor. Italian industry could not close the technological gap. The Ariete Division, whose tankers had first encountered Sherman sloped armor at El Alamein, earned its gold medal of military valor for conduct in multiple engagements including Tobruk, Bir el Gubi, Gazala, Alam el Halfa, and El Alamein. British and New Zealand accounts acknowledged the effectiveness of Italian armoured units when properly equipped and led, despite their obsolete equipment. British historian John Latimer assessed that Italian soldiers were tough and hardy, and on innumerable occasions they fought as bravely as any soldiers in the world. General Francesco Antonio Arena commanded the Ariete Division during its final battle at El Alamein on November 4, 1942. As his division was surrounded and destroyed, Arena sent a famous last message that captured both the desperate situation and the determination of Italian armor. Enemy tanks broke through south of Ariete Division, thus Ariete surrounded. Located 5 kilometers northwest of Bir el Abd, Ariete tanks are fighting. Second Lieutenant Luigi Arbib Pascucci of the Ariete Division exemplified the courage of Italian tankers even when facing impossible odds. On November 4 to 5, 1942, at the Second Battle of El Alamein, Pascucci commanded 11 M1340 tanks in a final counterattack against the British 8th Armoured Brigade. His action allowed the Ariete Division to retreat, though Pascucci himself was killed in the fighting. He was posthumously awarded Italy's highest military honour, the Medaglia d'Oro al Valor Militare. Today, the Italian Army's 13th Tank Battalion bears his name, M.O. Pascucci, honouring his sacrifice. The technical analysis of why Italian 47mm shells deflected off Sherman sloped armour is straightforward. The geometric principles are well understood. An armour plate angled at 56 degrees from vertical forces incoming projectiles to travel through 60% more material than the plate's actual thickness. A 50mm plate becomes effectively 90mm when measured along the projectile's path through angled armour. Italian guns capable of penetrating 70 to 80mm of vertical armour could not reliably penetrate 90mm of effective armour. But beyond the mathematics lies the human experience of Italian tankers who witnessed these principles in action. They had trained on equipment they believed adequate. They had scored victories against British armour in previous battles. They had developed skills and tactics that should have given them fighting chances in conventional armoured combat. Then they encountered Sherman tanks and discovered that clever design could render their training and equipment obsolete. The sloped armour that deflected Italian shells at El Alamein represented American industrial sophistication, applying scientific principles to mass production at overwhelming scale. It was proof that the United States had entered the war with industrial capacity and technical knowledge that Axis powers could not match. Italian tankers learned this lesson through fire and steel. They fired at Sherman tanks and watched their shells spark off sloped armour plates. They took return fire from 75mm guns that punched through conventional Italian armour with devastating efficiency. They fought with courage and skill, using equipment that could not compete. Those who survived carried that knowledge forward. Italian prisoners who witnessed American productive capacity understood why they had lost. Italian veterans who rebuilt their nation after the war supported democratic institutions and Western alliance based on what they had learned about American industrial might. The Sherman tank's sloped armor became a symbol not just of American engineering skill, but of the democratic industrial system that produced tanks by the thousands while maintaining quality and incorporating advanced design principles. The story of Italian tankers firing at Shermans and watching their rounds deflect is ultimately a story about industrial capacity, determining military outcomes. 47mm guns that should have penetrated 50mm of armor could not defeat geometric principles that transformed 50mm into 90mm of effective protection. Italian industry that had produced adequate tanks for 1940 could not match American industrial sophistication, applying advanced theory to mass production in 1942. No amount of courage or tactical skill could overcome that disadvantage. Italian tankers at El Alamein fought as bravely as any soldiers in the war. They scored hits on enemy armor, they executed proper tactics, they did everything their training and doctrine prescribed, and they discovered that modern warfare had evolved beyond their equipment's capability to compete. The sloped armor that deflected their shells was proof that some technological gaps cannot be bridged through determination alone. The mathematical reality was brutal and inescapable. Italian 47mm armor-piercing rounds, striking Sherman glacis plates at 56-degree angles, had insufficient energy to maintain trajectory through 90mm of effective armor. The shells deflected according to principles of ballistic physics that respected neither courage nor national pride. Italian tankers could aim perfectly, fire accurately, and still watch their rounds spark away without penetrating, because the design principles incorporated into Sherman armor rendered conventional Italian weapons inadequate. This was not a failure of Italian soldiers or Italian military skill. It was a failure of Italian industrial capacity to match American design sophistication and production scale. The Sherman tank incorporated sloped armor because American engineers understood the tactical advantages, and American industry could manufacture complex angled plates at massive scale. Italian tanks incorporated conventional armor because Italian industry prioritized production simplicity over optimal ballistic protection. By 1942, that choice had made Italian armor obsolete against enemies who had moved forward. The transformation of Italian soldiers from fascist believers to democratic advocates stemmed directly from this experience. They had been told that fascist strength would overcome democratic weakness. They had been taught that Italian equipment was adequate for the tasks ahead. They had believed that courage and skill would compensate for material disadvantages. Then they encountered Sherman tanks and discovered that industrial sophistication mattered more than propaganda could acknowledge. Italian tankers who survived El Alamein and subsequent North African battles became prisoners who witnessed American industrial capacity in operation. They saw factories producing war material in overwhelming quantities. They experienced treatment that contradicted everything fascist propaganda had taught about democratic nations. They returned to Italy after the war as witnesses to a better system, helping build the democratic republic that emerged from fascism's ruins. The sloped armor that deflected Italian shells at El Alamein represented more than engineering cleverness. It was physical proof that American democracy had created conditions where innovation flourished, where mass production thrived, where abundance was possible through free markets and free people. Italian tankers learned this lesson the hardest way imaginable. Through defeat on the battlefield, through watching their equipment fail against superior design, through witnessing the productive capacity of their former enemies and understanding why they had lost. The M1340 now sits in museums as a relic of a system that could not compete. The Sherman, though also retired, is remembered as a symbol of democratic industrial might applied to modern warfare. But the real legacy is not in the tanks themselves. It is in the Italian soldiers who fought in them, who survived, who learned, who changed their understanding based on evidence rather than propaganda. They discovered that 47mm shells deflect off armor angled at 56 degrees when the effective thickness exceeds their penetration capability. They learned that industrial systems matter more than individual courage in modern mechanized warfare. They witnessed American productive capacity and understood that some advantages cannot be overcome through determination alone. And they returned to Italy as advocates for the democratic system, whose superior design and industrial sophistication had defeated them. The geometry was simple. The consequences were profound. Italian tanks could not penetrate Sherman armor because American engineers understood ballistic principles Italian designers had not prioritized. Italian industry could not produce competitive tanks in adequate numbers because American industrial capacity exceeded Italian capabilities by orders of magnitude. Italian tankers fought bravely but lost because modern warfare respects physics and mathematics above human determination. That lesson transformed not just military doctrine but political understanding. The Italian soldiers who witnessed Sherman's superiority at El Alamein became prisoners who experienced American abundance. They returned home as advocates for democratic capitalism, who helped rebuild Italy as a modern nation allied with the power whose tanks had destroyed theirs. The sloped armor that deflected 47mm shells became a symbol of what democratic industrial systems could achieve and what fascist systems could not match. The Second Battle of El Alamein demonstrated through fire and steel that geometric principles matter in armored warfare. A 50mm armor plate angled at 56 degrees provides effective protection equivalent to 90mm of vertical armor. Italian 47mm guns could not penetrate 90mm of armor at combat ranges. Therefore, Italian tanks could not effectively engage Sherman tanks frontally, regardless of crew skill or tactical competence. The mathematics were simple. The consequences for Italian armor were catastrophic. Italian tankers who survived that revelation carried the knowledge forward. Some rebuilt Italy as a democratic republic. Some immigrated to America seeking opportunity in the nation whose industrial might had proven overwhelming. All understood that modern warfare had evolved beyond their equipment's capacity to compete, and that industrial sophistication determined outcomes more certainly than courage or tactical skill. The rumble of diesel engines in the Egyptian desert that October morning in 1942 marked not just the beginning of a battle, but the revelation of a truth Italian tankers would carry for the rest of their lives. Their 47mm shells deflected off Sherman's sloped armor, not because of crew failure or tactical error, but because geometric principles and industrial sophistication had rendered their equipment obsolete. That lesson, learned through defeat and witnessed through American abundance, helped transform Italy from fascist dictatorship into democratic republic, allied with the nation whose superior tanks had proven the decisive difference.